Hey. How are you, my friend? You are looking well confused.
I am having trouble understanding this thing they call testing and evaluating software.
Well, you have luckily found the one robot on Mars who understands everything about testing and evaluating software. Firstly, to understand it more clearly, you need to break it up into several parts. Firstly, testing the software solution. This involves comparing the solution with the objectives and design specifications of the original software idea. There are essentially two ways to test this solution framework. Both black box testing and white box testing. Black box testing is also known as functional testing. The inputs and outputs are known, but the processes are not. White box testing is also known as structural testing, which is a testing in which the internal workings of the item are known. There are 4 different levels of testing. These are unit testing, which tests the individual modules within your program. Integration testing, which tests the informations passed between these modules when the program is run. System testing, which is where the program's interaction with other programs is tested. And lastly, auto testing, which is where the interaction of the user is tested. Next, we analyze the use of live test data. Once a product goes live, turned on, it needs to undergo a series of tests to ensure its robustness under real conditions. This testing occurs using live test data. Many commercial applications obtain input from large databases. During development of software products, relatively small data sets are used. At the alpha and beta testing stages, large files should be used to test the system's performance. Testing needs to include random mixes of transaction types. During system testing, we need to test that transactions occurring in random order do not create problems. The response time is the time taken for a process to complete. The process could be user-activated or it could be activated internally by the application. Response times are dependent on all the system components, together with their interactions with each other and other processes that may be occurring concurrently. Large amounts of data should be entered into the new system to test the application under extreme conditions. Multi-user products should be tested with large numbers of users entering and processing data simultaneously. Large systems that require extensive data input require special consideration. An interface provides a communication link between system components. In terms of modules within a program, the interface is usually provided through the use of parameters that are used to pass data to and from modules. The screens of an application provide an interface between the users and the program. Hardware drivers are programs that provide an interface between applications and hardware devices. Programs that interact with other programs require an interface to complete the tasks. All these interfaces require testing. During previous stages of the software development cycle, test data together with expected outputs were created. This test data should be entered into the finished product to ensure correct outputs are obtained. Because the outputs are already known, this testing process ensures the final product is able to perform its processing correctly. Benchmarking is the process of evaluating a product, in this case a software product, using a series of tests. These tests provide numerical results that are compared with recognized standards. The process of benchmarking aims to compare the performance of a product with these standards. Results of benchmark tests are used to compare products. These results allow users of software products to make informed purchasing decisions. They also provide software developers with objective data, which can be used to compare their products with those of their competitors. The quality of a software product is measured against how well the product meets or exceeds users' expectations. Quality assurance is about ensuring that this occurs. In Chapter 1, we examined aspects of quality software. Each of these aspects requires testing and evaluation.
What about documentation of the testing process?
Glad you asked. A large variety of computer-aided software engineering tools are available for use during the testing and evaluation stage. These tools automate the more tedious tasks associated with the testing process. Many tools specialize in particular testing functions such as test data generation, user interface testing, or volume testing. Documentation and communication of the testing process and its results are vital to any testing program. Results of testing need to be evaluated and acted upon if the problems highlighted are to be corrected. For this to successfully occur requires documentation of the testing process and communication of the results to the development team and to users. The nature of the project will determine the audience for the test results. Projects written for a specific client will require communication of results directly to the client. Large software development companies usually have separate development and testing personnel. In this case, the testers must communicate their findings back to the development team. Often software developers outsource their system testing to specialists. If this is the case, the testing specialists must communicate their findings back to the software development company.
Wow, man, thanks. Now I know everything I need to for the future.
No worries, boss. See you around.
On the flip side, homie,